Poster number 1 presented by Professor Osama Osman titled Computational Notes on the Graphene Quantum Dots Substituted by Phosphorus, Arsenic, and Antimony Atoms. Graphene quantum dots are nanoscale structures of graphene having strong quantum properties and edge effects that result in unique properties. As shown in Figure 1, a graphene quantum dot in the shape of an armchair hexagonal C42 is subjected to substitution by phosphorus, arsenic, and antimony atoms. Density function theory calculations were used to investigate the influence of filling with 4 phosphorus, arsenic, and antimony atoms on armchair hexagonal C42. At the B3LYP 6 to 31 grams d.P. level, the effect of substitution on electronic characteristics was investigated using density functional theory. Some descriptors were calculated for model molecules to study the effect of substitution. Each structure is optimized, then some parameters are calculated, including total dipole moment, the high occupied molecular orbital and the lowest unoccupied molecular orbital bandgap energy, and the molecular electrostatic potential. The reactivity of the studied surfaces is indicated in terms of the calculated molecular electrostatic potential, MESP. After collecting the studied parameters together, a computational note will dedicate the studied GQDs for appropriate applications.
This poster undertitled The Electronic Properties of Graphene Quantum Dots Substituted with Aluminum, Gallium, and Indium Atoms. The major aim of this study is to develop the electronic properties of armature hexagonal C42 graphene quantum dots by decoration with aluminum, gallium, and indium atoms. All calculations are carried out utilizing Gaussian 09 packages at Spectroscopy Department National Research Center. Building model molecules, the supposed structures of graphene quantum dots consisting of 42 atoms of carbon with armature zigzag edges. The electronic properties of armature hexagonal graphene quantum dots were tuned by substitution with the aluminum, gallium, and indium atoms in 4 different positions. The results indicated that the electronic properties of graphene quantum dots in the armature hexagonal shape substituted with aluminum, gallium, indium atoms or in the 4 different positions were investigated successfully using density functional theory. The electronic properties of the studied structures were calculated using the P3-lib method. The replacement of carbon atoms with aluminum, gallium, and indium atoms increases the total dipole moment of armature hexagonal C42 while decreasing the HOMO-LUMO band gap energy. The replacement with 2 aluminum atoms is the most effective model as the band gap decreased from 3.4 to 0.2 electron volt. The molecular electrostatic potential maps revealed that the reactivity of armature hexagonal C42 was increased by substitution with 1, 3, and 4 atoms of aluminum and with 1, 2, and 4 gallium atoms. Meanwhile, the substitution of armature hexagonal C42 with indium atoms doesn't affect the reactivity. As a result, replacing carbon atoms with aluminum and gallium enhanced the surface reactivity of armature hexagonal graphene quantum dots.
Poster number 4 presented by Professor Abdul Aziz Mahmood titled Density Function Theory Calculations for Graphene Quantum Dots Filled with Aluminum, Gallium, and Indium. Density function theory calculations were used to investigate the influence of filling with 4 aluminum, gallium, and indium atoms on graphene quantum dots in the armchair triangle cut. Some descriptors were calculated for model molecules to study the effect of substitution. Such descriptors, including the total dipole moment, the high occupied molecular orbital and the lowest unoccupied molecular orbital bandgap energy, and the molecular electrostatic potential, were computed. To investigate the electronic properties, B3LYP 6 to 31 grams d.P. level for aluminum and gallium and B3LYP 3 to 21 grams level for indium were used. According to the calculations, the band gap result indicated that the armchair triangle graphene quantum dot band gap decreased with the filling of aluminum and gallium, especially with the filling of 2 atoms. Also, in the instance of indium, filling with 4 atoms was the most effective on the armchair triangle graphene quantum dot band gap. Furthermore, the molecular electrostatic potential map results showed that the armchair triangle graphene quantum dot map was not affected by filling with 2 and 4 atoms of aluminum, gallium, and indium. Finally, all result indicated that in the case of 1 and 3 aluminum, gallium, and indium substitutions, the surface of the armchair triangle graphene quantum dot layer enhanced sensitivity and surface area. Number 5, titled Effect of Hydration on the Physical Properties of Graphene Quantum, presented by Medhad A. Ibrahim, Spectroscopy Department, National Research Center, Giza, Egypt. Graphene quantum dots having strong quantum property and edge effects resulting in exceptional physical, as well as chemical properties. Accordingly, 4 types of graphene quantum dots, namely armchair triangle C60, armchair hexagonal C42, zigzag hexagonal C54, and zigzag chair triangle C46, were subjected to quantum mechanical calculations at DFT V3LYP 6 to 31 grams dP. Each model is subjected to hydration up to 6 water molecules. Total energy, total dipole moment, and the high occupied molecular orbital and lowest unoccupied molecular orbital bandgap energy were calculated. Results indicated that the total dipole moment of armchair triangle is increased because of increasing the water molecules, while increasing water molecules slightly decreases the bandgap energy. The same is regarded for other types of GQDs. Another important effect for hydration is to map the molecular electrostatic potential MESP for the studied models to indicate the active sites upon the surface of GQDs. Results indicated that water as polar molecules redistribute potential all around the surface of GQDs.
This poster undertitled on the substitution of aluminum, gallium, and indium with the graphene quantum dots. The main objective of this study is tuning the electronic properties of graphene quantum dots by decretion with aluminum, gallium, and indium atoms to enhance its surface reactivity. Calculation details: model molecules representing graphene quantum dots, Z hex C54 and Z hex substituted with aluminum and gallium, are subjected to optimization utilizing density functional theory at P3 lab 6 minus 31 GDB basis set, while all calculations for the indium atoms are running at P3 lab 3 minus 21 G star level of theory. The conclusion: density functional theory have been used to study the electronic properties of the proposed structure of zigzag hexagonal graphene quantum dots consisting of 45 carbon atoms and graphene quantum dots substituted with aluminum, gallium, and indium atoms. The substitution of Z hex graphene quantum dots with aluminum, gallium, and indium atoms significantly increases the total dipole moment, especially in the case of substitution with gallium. The increase in the total dipole moment values reflected the high reactivity of the studied structures. Additionally, increasing the number of aluminum and gallium atoms results in an increase in the total dipole moment values. However, the total dipole moment values increases with increasing the indium atoms to 3 dpi. Additionally, the substitution of carbon atoms with aluminum, gallium, and indium results in a decrease in the band gap energy of Z hex C45 carbon atoms. Increasing the number of substitution atoms changes the band gap energy values irregularly. Based on the obtained results, it can be concluded that the most reactive structures are that consisting of 3 aluminum atoms, 4 gallium atoms, and 2 indium atoms. Moreover, the substitution of Z hex C45 with 4 gallium atoms has the highest electronegativity due to the small value of the optical band.
Poster number 8, presented by Professor Osama Osman, titled Modeling Study of Aluminum, Gallium, and Indium, Substituted Graphene Quantum Dots. Graphene quantum dots are a cutting-edge material that has excellent electrical, thermal, and mechanical characteristics, as well as minimal toxicity and powerful photoluminescence. These unique properties give graphene quantum dots the ability to be used in different electrical, optical, and optoelectric applications. Graphene quantum dots with functionalization, substitution, and/or doping have lately become a significant stage in developing improved materials with the qualities necessary to fulfill application requirements. So, in this work, graphene quantum dots were substituted by 4 aluminum, gallium, and indium atoms in the shape of a zigzag triangle for density function theory calculations to study the change in electronic properties. The density function theory was used to calculate the total dipole moment, the high occupied molecular orbital and lowest unoccupied molecular orbital bandgap energy, and the molecular electrostatic potential. The basis sets employed in the model structure were 6 to 31 grams dP for aluminum, gallium, and indium, and B3LYP, 3 to 21 grams for aluminium. The substitution of aluminum, gallium, and indium atoms increased the total dipole moment of graphene quantum dots while decreasing the band gap, especially when 2 atoms were filled. The substitution of 2 aluminium atoms was the most significant in lowering the band gap, dropping it by 0.122 electron volt. Whenever the loading atoms were increased, the molecular electrostatic potential map indicated that the red color on the graphene quantum dot map had changed from being isolated on one triangle side to being spread over the graphene quantum dot surface. As a consequence, the reactivity and surface area of the graphene quantum dot surface increased according to the substitution of 4 aluminum, gallium, and indium atoms.
Hi everyone, I will talk about the most trendy advanced two-dimensional material nowadays and its ability for sensing of carcinogenic materials. Our title here is Ability of Trihalomethane Sensing Using Functionalized 2D Mixing, which had a formula of Ti multiplied by N plus 1, C multiplied by N, and T multiplied by N, which T can be fluoride ions, chloride ions, oxygen ions, and hydroxyl ions. The problem statement can be stated here when we mentioned the interaction of trihalomethane, the most common group of carcinogenic chlorination byproducts of water sanitation, with a pristine mixine monolayer and the many types of terminal function groups that can be placed on the surface are subject of this study. The total dipole moment increased, stepping for all mixine in oxygen hydroxyl ions, mixine oxygen fluoride ions, mixine oxygen chloride ions, mixine hydroxyl fluoride ions, and the mixine fluoride chlorine ions, and the mixine hydroxyl chloride ions, respectively, along with increasing in band gap energy to be 0.734 and 0.940 and 1.120 and 0.835 and last finally 0.927 electron volt. The computed result lead to the conclusion that termination atom's nature and the number had a variable and growing effect on the primitive mixine total dipole value. Utilizing the density functional theory (DFT), the absorption energy of trihalomethanes on the surface of different mixine types were determined. The most reactive and stable chlorinated structure with a total dipole moment of 12.443 dpi and the band gap of 0.570 electron volt was produced through geometry optimization and computation. Since the mixine chloride layer may function as a sensor for most common types of trihalomethane species. Thanks.
I am Asma Muhammad Ismail. I am researcher in Spectroscopy Department, National Research Center. My poster entitled On the Molecular Spectroscopic Analysis of Ketosane Iron Oxide Nanocomposite. In this work, we discuss the effect of addition of iron oxide on ketosane to be used as a biosensor for amino acid glycine. As known, ketosane is an amino acid polysaccharide and it's biocompatible and has many applications in medical field. Also, iron oxide are the most famous and popular kind of magnetite nanomaterials and are used in many applications because of their low cost, low toxicity, and good magnetic properties. The magnetic nanomaterials are mainly prepared in the presence of two major aqueous solution, which are ferrous and ferric as cleared in the preparation scheme. As observed, FTIR and XRD confirmed the complexation and interaction between ketosane and iron oxide, as also banded energy and absorption age changed on the addition of iron oxide on ketosane, which indicated the high density of the localized tail state in ketosane iron oxide nanocomposite. Also, UV visible spectroscopy results indicate that ketosane with 0.25 iron oxide ratio has the best sensitivity compared to pure ketosane and other ketosane iron oxide nanocomposite. Correlating the obtained data together, it can be concluded that ketosane iron oxide could act as a biosensor for the amino acid glycine.
عنوان البحث وهو تقييم الخصائص البصرية للأغشية الرقيقة ذات التركيب.
بسم الله الرحمن الرحيم. I am Isra Sulaiman Ahmad, master's student in the Department of Physics, Faculty of Women for Arts, Science and Education in Shams University. This poster is about energy storage, overview and outlooks. Aim of the research is studying the electronic properties of graphite, graphene and fluorine in order to investigate for energy storage application. The energy, environment and economy are the most fundamental global issues for our sustainable future. While energy is the most visual requirement for the progress of our civilization, where our current global energy consumption is about 15 terawatt, and we have become dependent on energy in various fields, where the statistic followed global energy consumption by sectors for the year 2021 is as 30% for transport sectors, 20% for industrial sectors, 13% for residual and chemical sectors, 36% for electrical power. So the statistic followed global energy consumption by different sectors as 33.6 for petroleum oil, 23.9% for natural gas, 27.2% for coal, 4.4% for nuclear energy, 6.8% for hydroelectricity, and for renewable energy 4%. That is almost 85% of energy is based on fossil fuels. It is expected that the global energy consumption increase with increasing technological and industrial development during the next 10 years. The only way to address this situation is to depend on renewable sources, but renewable sources are intermediate sources, and here came the concept of energy storage, as the energy storage provides resiliency, helps integrated renewables, provide financial benefits to minimize the dependence on fossil fuels. Hydrogen is regarded as the most promising energy carriers because its release is completely free from environmental hardness. And there is two ways for storage hydrogen are physical based and material based. physical base is requirements and technological that are costing, and the material based is the best ways to the storage hydrogen, like liquid organic, metal hydrates, and complex hydrates, and the carbon materials. And thank you for your attention.
Computational notes on the effect of lithium, sodium, and potassium on the vibrational spectra of fatty acid by شيماء جمال, فاطمة عادل, and محمد المنسي. Physics Department, Faculty of Women for Arts, Science and Education, عين شمس University, Cairo, Egypt. Department of Physics, Faculty of Education, عين شمس University, Roxy, Cairo, Egypt. Fatty acid derivatives are the primary components of lipids, a model molecule of fatty acid which is composed of hydrocarbon chain terminating with carboxylic group. The model is subjected to molecular modeling calculation using the FT level of theory. Operational assignment of the model molecule is given in terms the calculated infrared and Raman are calculated at the same level of theory. For each band, the band position and its assignment is given. Besides vibrational characteristics, some important physical parameters are also indicated at the same level of theory. The parameters including HOMO-LOMO, band gap energy, and total dipole moment. Building a model molecule, the proposed structure of the studied fatty acid, new vitidine, consists of 20 atoms of carbon and 38 atoms of hydrogen attached to one carboxylic group. The activity of the new vitidine acid was improved by the substitution of hydrogen atom of the carboxyl group with different alkali metals such as lithium, sodium, and potassium. FTIR analysis. Figure 1 presents the IR spectra of new vitidine acid and new vitidine substituted with lithium, sodium, and potassium calculated at the FT. The C double bond O stretching vibration of the new vitidine's carboxyl group is found at 1839. C double bond O is shifted to the lower wave number region via interaction with lithium, sodium, and potassium cations. The OH scissoring for primary is found at 682, while OH wagging is at 554. Opens interaction with lithium, sodium, and potassium cations. H protons splitting takes place. The scissoring mode is shifted to the higher wave number region and observed at 753, 727, and 715 centimeters minus 1 for lithium oxygen, sodium oxygen, and potassium oxygen functional respectively. Also, wagging mode is shifted to 644, 618, and 603 centimeters minus 1 for lithium oxygen, sodium oxygen, and potassium oxygen functional respectively. Computational notes on the effect of lithium, sodium, and potassium on the vibrational spectra of fatty acid by شيماء جمال, فاطمة عادل, and محمد المنسي. Physics Department, Faculty of Women for Arts, Science and Education, عين شمس University, Cairo, Egypt. Department of Physics, Faculty of Education, عين شمس University, Roxy, Cairo, Egypt. Fatty acid derivatives are the primary components of lipids, a model molecule of fatty acid which is composed of hydrocarbon chain terminating with carboxylic group. The model is subjected to molecular modeling calculation using the FT level of theory. Operational assignment of the model molecule is given in terms the calculated infrared and Raman are calculated at the same level of theory. For each band, the band position and its assignment is given. Besides vibrational characteristics, some important physical parameters are also indicated at the same level of theory. The parameters including HOMO-LOMO, band gap energy, and total dipole moment. Building a model molecule, the proposed structure of the studied fatty acid, new vitidine, consists of 20 atoms of carbon and 38 atoms of hydrogen attached to one carboxylic group. The activity of the new vitidine acid was improved by the substitution of hydrogen atom of the carboxyl group with different alkali metals such as lithium, sodium, and potassium. FTIR analysis. Figure 1 presents the IR spectra of new vitidine acid and new vitidine substituted with lithium, sodium, and potassium calculated at the FT. The C double bond O stretching vibration of the new vitidine's carboxyl group is found at 1839. C double bond O is shifted to the lower wave number region via interaction with lithium, sodium, and potassium cations. The OH scissoring for primary is found at 682, while OH wagging is at 554. Opens interaction with lithium, sodium, and potassium cations. H protons splitting takes place. The scissoring mode is shifted to the higher wave number region and observed at 753, 727, and 715 centimeters minus 1 for lithium oxygen, sodium oxygen, and potassium oxygen functional respectively. Also, wagging mode is shifted to 644, 618, and 603 centimeters minus 1 for lithium oxygen, sodium oxygen, and potassium oxygen functional respectively.
Bismillahirrahmanirrahim. This article is development of mechanical and physical properties of material using a new irradiated ferrous alloy. The abstract the purpose of this paper to study the physical properties of new alloy. The alloy contains mainly from steel. The change in constitute of alloy to development the mechanical properties of material to use in wide range of industrial applications. In this work, the effect of neutron radiation on hardness of material also is studied. This table 1, shows the contents of added elements of the main material. Is the conclusion of this paper. The hardness increases with the neutron irradiated. The atoms of this of the steel rearranged after neutron irradiation. The material which added enhances the mechanical properties. Thank you.
Glucose sensing utilizing biosensor based on graphene oxide, zinc oxide, polyvinylidene fluoride ADFD approach, presented by Manor Subhi. Hyperglycemia, high blood glucose, is poised to be one of the biggest healthcare situations in the coming decades, as major efforts are being put into new glucose monitoring systems. Accordingly, graphene oxide, zinc oxide, polyvinylidene fluoride model molecule-based biosensor was built up for glucose sensing. The proposed structures were optimized using the density functional theory at P3 lab and L to DZ level of theory. Total dipole moment, homolomo band gap energy, and molecular electrostatic potential were studied to demonstrate the findings. Firstly, building the model molecule of graphene oxide. After that, finding the total dipole moment and homolomo band gap energy with molecular electrostatic potential of graphene oxide. Then, the interaction of graphene oxide with zinc oxide occurred at terminal and middle on graphene oxide. The results show that the model molecule representing graphene oxide interacted with zinc oxide throughout the carboxyl group possesses the highest total dipole moment and lowest homolomo band gap energy. Additionally, the incorporation of the polyvinylidene fluoride to a graphene oxide zinc oxide molecule reduces the total dipole moment and homolomo band gap energy. Moreover, the molecular electrostatic potential shows that the interaction of the polyvinylidene fluoride with the graphene oxide zinc oxide model molecule increases the reactivity of graphene oxide zinc oxide molecule. Finally, the absorption of the glucose molecule to graphene oxide zinc oxide polyvinylidene fluoride model enhances the reactivity of the graphene oxide zinc oxide polyvinylidene fluoride molecule as total dipole moment increases and homolomo band gap energy increases slightly. This result shows that the graphene oxide zinc oxide polyvinylidene fluoride based biosensor is a good candidate for glucose sensing.
Welcome to our poster session. Poster number 23, Electronic Modification of PVDF Hybrid Membrane Experimental and Theoretical Approach, presented by Amina Omar, Lecturer of Biophysics, Faculty of Science and Shamsi University. In this work, we are focused in PVDF polymers. PVDF polymers is type of fluoropolymers, and which is the most common commercial and piezoelectric polymers that has promising use in smart biomedical and industrial membrane. Interaction of this zinc oxide and reduced graphene oxide polymer increase the beta phase of this polymer. Our work for making experimental and computational work. The experimental work focused in preparation of graphene oxide and reduced graphene oxide, zinc oxide, and forming hybrid membrane of PVDF with zinc oxide and reduced graphene oxide. And the computational work by using calculated of optimization and mapping electrostatic potential for this interaction through zinc oxide and graphene oxide. From the result of experimental work, the prepared PVDF hybrid membrane is characterized by XRD, FTIR, scanning, and EDAX. And we are forming from the experimentally that the senses of the PVDF zinc oxide membrane and the PVDF zinc oxide reduced graphene oxide membrane. And theoretically, from the DFT calculation, concluded that the PVDF interacted with the zinc oxide through the zinc, and their ability to interact with graphene, yielding a highly stable and highly reactive structure, which enhance the potential for this hybrid membrane for using for virus biological application. Now, the poster number 24 of polymethyl methacrylate PVDF hybrid membrane reinforced with 2D zinc oxide and graphene oxide theoretical and experimental approach, presented by Amina Omar, Lecturer of Biophysics, Faculty of Science and Shamsi University. In this work, also we focus on PVDF polymers, but we are reinforced it with the polymethyl methacrylate and forming composite between the polymethyl methacrylate and PVDF. Also, we have experimental and theoretical approach. The experimental work focus on the preparation of the graphene oxide with zinc oxide and the hybrid membrane and the composite membrane between polymethyl methacrylate and PVDF and graphene oxide and zinc oxide. And the computational work also making by density functional theory to have the mapping electrostatic potential and HOMO-LOMO orbital distribution. From the experimental result, we focus on XRD and FTIR and UV visible to have the band gap. And we are, from the result, we are ensure that the senses of polymethyl methacrylate PVDF graphene oxide and for hybrid membrane, and also for polymethyl methacrylate PVDF zinc oxide graphene oxide hybrid membrane. And from theoretical results, we have the total dipole moment and the band gap energy and the molecular electrostatic potential calculation reveals that the novel structure of the polymethyl methacrylate PVDF zinc oxide graphene oxide composite has the lowest band gap and the maximum total dipole moment, which enhances the potential for optoelectronics material.
Synergistic interaction between noble two-dimensional material reduced graphene oxide and biodegradable natural polymer sodium alginate was created by green and simple method to form unique microsphere with needle shape acting as super encapsulation and sustained release machine for highly effective and remarkable antibiotic cefotaxime. We developed three forms of microsphere: alginate cefotaxime, and alginate cefotaxime graphene composite were prepared using calcium chloride as a cross-linking agent and characterized using field emission scanning electron microscopy and Fourier transform infrared spectroscopy to investigate the pores, roughness, surface morphology, and to analyze the functional groups of the microspheres respectively. XR diffraction was employed for the identification of phase formation, purity, and structural properties. Membrane diffusion method was employed to determine release profile of cefotaxime from the fabricated microspheres. Antibacterial activities of cefotaxime solution, alginate microspheres, alginate cefotaxime microspheres, and alginate cefotaxime graphene oxide microspheres were investigated against gram-negative bacteria Escherichia coli using agar diffusion method on molar Hinton agar. The prepared samples gave excellent results.
Poster number 26 titled Electronic Properties and Molecular Electrostatic Potential Mapping of Graphene Quantum Dots Decorated with Zinc Oxide, Copper Oxide, and Titanium Dioxide, presented by Asma Ibrahim. Graphene quantum dots, hexagonal and triangle cuts with armature and zigzag ends, were decorated with different metal oxides such as zinc oxide, copper oxide, and titanium dioxide. The impact of metal oxide decoration on the electronic characteristics of graphene quantum dot was investigated using homolomo orbital distribution and molecular electrostatic potential mapping calculation. The model structure were calculated using density function theory. Calculation details: quantum dots in 4 different forms interacted with metal oxides such as zinc oxide, copper oxide, and titanium dioxide following the density function theory B3 lib LAN L2DZ model calculations. Models proceeds with Gaussian package at molecular spectroscopy and modeling unit, National Research Center, Egypt. The total dipole moment, homolomo the orbital distribution, and molecular electrostatic potential mapping were conducted for the studied model structures to investigate electronic properties of a chosen graphene quantum dots shapes interacted with zinc oxide, copper oxide, and titanium dioxide. Objective: tuning the electronic properties of graphene quantum dots by decoration with zinc oxide, copper oxide, and titanium dioxide. Conclusion: density function theory have been used to study electronic properties of graphene quantum dots and graphene quantum dots attached with metal oxide. The attachment of metal oxide significantly increased the total dipole moment with very high value observed in graphene quantum dots attached with zinc oxide. The increase in total dipole moment reflects the fact that the given structure are highly reactive with their surrounding media. The adding of metal oxide decreases the band gap energy. The most effective metal oxide of graphene quantum dots was titanium dioxide that enhanced band gap energy, and the theoretical IR of graphene quantum dots of various forms was computed and compared to FTIR spectrum of produced graphene quantum dots. From the result, the characteristics band of theoretical IR spectra of several kinds of quantum dots are almost the same as in the experimental spectra.
Hello everyone, I'm glad to be with you today presenting our group's work, including myself, Salma Yunus, Ahmed Al-Sayed, Suhaila Salah, Dr. Amina Omar, and Dr. Medhat Ibrahim. Our work entitled Computational Notes of Catechol O-methyltransferase Inhibitors for Parkinson's Disease, a Treatment. Parkinson's disease affects the nervous system, which arises in several physical motions due to the depleted dopamine levels. Through dopamine pathway here, we can see vital enzymes such as RCUMT or catechol O-methyltransferase, which converts neurotransmitters such as dopamine into their methylated form. The medications rely on dopamine replacement, like levodopa. When levodopa enters the body, it's converted into its methylated form through a CUMT enzyme, peripherally, thus decreasing the percentage of levodopa that enters the blood-brain barrier. When the levodopa crosses the blood-brain barrier and generates dopamine, the CUMT do his job one more time and convert the dopamine into its methylated form, thus decreasing a dopamine level. As we can see here, blocking CUMT action can arise with increasing levodopa bioavailability as well as dopamine levels. There are 2 FDA-approved inhibitors for CUMT, but they fall short to influence the fluctuations in the levodopa plasma profile, and one of them do not penetrate the blood-brain barrier. Here we are suggesting 5 new drugs through QSAR analysis that penetrate the blood-brain barrier, and comparing them with widely known inhibitor called 3,5-dinitrocatical or DNC. The suggested drugs have been chosen according to their pharmacophores. They are all catechals, so they can provide competitive inhibition of enzyme. Firstly, as you can see here, we draw the interactions between enzyme pocket and the drugs. Each drug is interacted through two hydrogen bonds between two residues, which are glutamate 199 and lysine 144. Also, there are two coordination bonds with magnesium ion. We did a QSAR analysis by calculating electronic descriptors like energy gap and hydrophobic descriptors like the partition coefficient, and also there are steric descriptors like molar refractivity. From the results, we can conclude that there are two promising drugs that penetrate blood-brain barrier, having more stable interaction with enzyme corresponding comparing to original drug, and have larger gap energy than DNC. Thus, they are less reactive toward the surrounding, and they can also fit into the bucket according to volume and surface calculations. Thank you.
Welcome to our poster session. Now the poster number 28 on the title Molecular Modeling Approach of Effect of Graphene Oxide, Titanium Oxide, and Silicon Oxide on Phospholipid Membrane is presented by Dr. Amina Omar, Lecturer of Biophysics, Faculty of Science, and Shamsi University. The membrane is an important component of a biological cell because it separates the content of the cell and organism from the surrounding fluid. The membrane composed of phospholipids, bilayers, and protein. The membrane phospholipids are one of the primary components of the cell membrane, which are selectively permeable and thus regulate the entry and exit of material or molecules in the cell. The phospholipid composed of hydrophilic head and hydrophobic tail. Changing the composition of the hydrophobic head and hydrophobic tail is changing the type of phospholipids membrane. There are two types of the membrane phospholipids, glycerophospholipids and sphingolipids. In this work, الفوسفوديالكولين POC and الفوسفوethanolamine as a type of glycerophospholipids and sphingomyelin PSM as a type of sphingolipids. The molecular interaction of these phospholipids and its interaction with the nanomaterial as graphene oxide, titanium dioxide, and silicon oxide through oxygen of phosphate group of the phospholipids are calculated by using density functional theory. The calculated electronic properties and mapping electrostatic potential indicating the high reactivity of phosphocholine POPC and the phosphoethanolamine POPE interacted with the titanium oxide and sphingomyelin PSM interacted with silicon oxide. And from the result of the QSR parameter calculated at PM6, indicating increasing of lipophilicity for the phospholipids interacted with the titanium oxide and silicon oxide, which mean increasing absorption of this oxide on the surface of the membrane phospholipids to be used for different biotechnological and biomedical application.
Poster number 29, and its title is Functionalized Alumina Nanoporous Membrane for Neural Disease Treatment, presented by me, Nuran Ismat Said. One of the problematic issues in conventional treatment methods for the neural disease is their spread to other organs rather than the targeted nervous system, which causes toxic effects to the vital organs. So, in this work, we focused on using nanoporous alumina membranes as a drug carrier in order to overcome these problems. Nanoporous alumina membranes were prepared by a two-step electrochemical anodization method. The preparation process divided into 6 main steps. The first step is the pre-treatment step, in which the aluminium sheets were heated at oven at 500 degrees and then sonicated in sodium hydroxide and acetone. After that, the electropolishing step, in which the aluminium sheets were electrochemically polished in a mixture of perchloric acid and ethanol to reduce the surface roughness. After that, the aluminium sheets were first anodized in 0.3 molar oxalic acid at a potential of 40 volts for 5 hours. Second anodization was carried out similarly as in the first anodization, but for different time. Between the two steps of anodization, a selective remover of the porous oxide layer obtained by first anodization was done to pre-structure the aluminium surface. This etching process has to be done using a mixture of chromic acid and phosphoric acid at 73 degrees. The resulting inner surface of aluminium exhibits a uniform concave nanoarray based on which an ordered pore size distribution can be built. These nanoporous aluminum membranes were characterized by scanning electron microscopy, atomic force microscopy, and X-ray diffraction analysis. Density functional theory calculations were performed on aluminum membranes coated with different coating polymers as BVDF and BVB to test the biological activity of these coating materials on the surface of aluminum membrane. The results in table showed that structure number 8 was more stable and had lowest energy and highest reactivity. So this aluminum membrane can be used as a drug carrier for the treatment of neural disease.
السلام عليكم ورحمة الله. Here with you, Dr. Hoda Samir, lecturer of Pharmaceutical Organic Chemistry, Faculty of Pharmacy Girls in Azhar University. I'm very delighted to represent my work in the 4th Hybrid International Conference for Molecular Modeling. Our research, which is entitled Structure-Based Design and Synthesis of 3,7-nitro, 3-oxo, 3,4-dihydrocanoxylene 2-I-propane hydrazide derivatives as novel bacterial DNA gyrase inhibitors in vitro, in vivo, in silico, and SOR studies. And antimicrobial resistance is one of the critical challenges that have been encountered over the past years. So, a novel series of 3,7-nitro, 3-oxodihydrocanoxylene 2-I-propane hydrazide derivatives 3,2,6-E compounds were designed and synthesized employing the canoxylene 2-on scaffold and relying on the pharmacophoric features experienced by the quinolone antibiotic derivative, quinolone antibiotic canoxylene. The in vitro antibacterial activity of the synthesized compounds was assessed using 8 different gram-positive and gram-negative bacterial species, and among which compound 6D and 6E displayed promising antibacterial activity. Furthermore, compounds 6D and 6E showed minimum inhibitory concentration better than ciprofloxacin regarding the Staph aureus and Staphylococcus pneumonia bacterial species. Also, the cytotoxicity assay result of compound 6D and 6E using the human WI38 cell line was assessed, showing their safety and selectivity. Additionally, the DNA gyrase inhibition assay for compound 6D and 6E was carried out, and compound 6D and 6E disclosed promising IC50 against the DNA gyrase comparable to ciprofloxacin. Compound 6D and 6E were further assessed via in vivo approaches, blood count, liver and kidney function, and histopathological examination. Both compounds were found to be safer on liver and kidney than the reference drug ciprofloxacin. Moreover, molecular docking studies revealed reasonable binding affinities for all compounds, particularly compound 6D, which showed better binding and stability in the DNA gyrase binding pocket than the ciprofloxacin. Also, the Swiss Adam studies revealed the bioavailability of all compounds and GIT absorption without passing blood-brain barriers, which ensure the compound's safety. Finally, the SAR studies, or structure activity relationship studies, were established, which unveiled that not only the quinoxaline main pharmacophores are important for biological activity, but also derivatization with aryl aldehydes is essential for enhanced antibacterial activity. Thank you.
Hello, I'm Dr. Fatma Gamal Abdurrahman, lecturer in the Pharmaceutical Organic Chemistry Department, Faculty of Pharmacy, Al Azhar University. I am very delighted to represent my poster in the 4th Hybrid International Conference of Molecular Modeling and Spectroscopy. Senses, cytotoxicity, evaluation of some novel benzochromine, benzochromino-pyridine, and benzochromino-pyrimidine derivative. Novel anti-cancer agents were designed to be sensitized depending on the reported anti-cancer activity of subchromine-containing scaffold, such as tolopulin, which is in stage 2 trial for treatment of solid tumors. In the current work, 2-amino-4-phenyl 4H-benzochromine 3-carbonitrile 1 has been utilized for synthesis of various fused benzochromino-pyridine 2,2,6, which is presented in scheme number 1, benzochromino cyclopentapyridine 7A, benzochromino quinoline 7B, benzochromino benzofluoropyridine 9, which is presented in scheme number 2, as well as 2,3 substituted benzochromine 8, 10, 12, and benzochromino-pyrimidine 11 and 13 analogues through different chemical reactions. The newly sensitized compounds were tested against 3 cancer cell lines, including liver cancer, HIF-G2, breast cancer, MCF7, and prostate cancer, BC3, among which compounds 3, 4, 5, 8, and 11 were found to possess potent anti-cancer activity against the selected cancer cell lines. The HIF inhibition investigation for analogues 3, 4, 5, 8, and 11 was carried out in comparison with cathepsin as a standard drug, where compound 8 containing benzochromino 2-yl aminobutanoic acid scaffold exerted significant HIF inhibition action that is higher than the standard drug. Thank you.
Cardiovascular protection, atherosclerosis by Said Elwi from Faculty of Pharmacy, Ain Shams University, Cairo, Egypt.
Abstract atherosclerosis is the buildup of fats, cholesterol and other substances in and on the artery walls. This buildup is called plaque. The plaque can cause arteries to narrow, blocking blood flow. Atherosclerosis is a chronic and progressive disease arising from the inflammatory processes and oxidative stress within the vessel wall. There are some drugs like curcumin, berberine, quercetin, resveratrol, and dihydrotensionone that have been shown to exhibit anti-atherosclerotic action through protection against inflammation and oxidation, modulation of cholesterol homeostasis and inhibition of platelet aggregation. These drugs are beneficial in lowering low-density lipoprotein cholesterol (LDL) and raising high-density lipoprotein cholesterol (HDL) while reducing lipid peroxidation. Animal studies in high-fat-fed atherosclerotic rabbit model have revealed that curcumin effectively inhibits LDL oxidation and decreases cholesterol and triglycerides levels. Accordingly, density functional theory (DFT) at B3-LYP 6 to 31 grams d/p level of theory was utilized to study the electronic properties of curcumin, berberine, quercetin, resveratrol, and dihydrotensionone. Calculation details. All calculations were performed using Gaussian 09 program at Molecular Spectroscopy and Modeling Unit, National Research Center, Cairo, Egypt. The molecules were computed using density functional theory at the B3-LYP 631 grams dp level of theory. Additionally, molecular electrostatic potential, HOMO-LUMO band gap energy, and total dipole moment were calculated at the same level of theory.
Synthesis, DFT calculations, in silico studies, and biological evaluation of pyrino 2,3 pyrazole pyrino 2,3 dipyrimidine derivatives presented by Asma Abo Elnaga Chemistry Department, Faculty of Women's of Arts, Science, and Education, Ain Shams University, Heliopolis, 11757, Egypt. The authors, Mohammed Jiabalan Ine, Abdelhamid Ismailo Asma Abo Elnaga Mohammed Tantor Inora, Elabai Aryan Sami Elisali. In this project, an eco-friendly approach was adopted for designing pyrino 2,3 C-pyrazoles from M1 to M25 via a one-pot reaction of hydrazine hydrate, ethyl acetostate or diethylmelanate, carbonyl group source, and active methylene compounds. Besides, pyrazole 4,3:5,6 pyrino 2,3 dipyrimidines M26 M31 was synthesized via intramolecular cyclization of M10, M13. Thereafter, the antimicrobial, antioxidant, and anti-cancer efficiencies of the titled compounds were assessed utilizing an assemblage of techniques. Fortunately, the vast majority of the compounds manifested auspicious biological outcomes. Over and above, in silico studies were employed to demarcate the synthesized compound's conceivable mode of action. M21 was the most auspicious antibacterial agent, while M5 was the most cytotoxic compound. Additionally, the bioinformatics study for M5 and M21 was implemented for predicting the drug likeness and physicochemical properties. Depending upon 6 characters, comprising size, MW between 150 and 500 grams per mole, lipophilicity, XLOG3 among 0.7 and plus 5.0, solubility, log S6, polarity, TPSA among 20 and 130 A ring, flexibility, 9 rotatable bonds, and saturation, the sp3 hybridized carbons, 0.25. The convenient physicochemical possessions for oral bioavailability was adjusted by the produced bioavailability radar. As represented in the boiled egg paradigm, M5 and M21 do not permit the blood-brain barrier, BBB, revealing good water solubility, bioavailability, and pharmacokinetics with high gastrointestinal absorption, GI, and according to drug discovery Lipinski rule of 5, they also have good drug likeness properties deprived of any violation. Finally, DFT theoretical calculations were used to study the stability and structural parameters of the newly synthesized compounds. DFT calculations showed the energy gaps between the HOMO-LUMO energy gap with all investigated compounds in a range of 4.04 to 5.66 electron volts, allowing for easy exchange of electrons and reactivity. By measuring the chemical hardness of the resistance to change the electron cloud density of a chemical system, it was found that M5 and M8 had the lowest value compared with the other investigated derivatives through 2.029851 electron volts, and 2.193255 electron volts, respectively, while M20 had 2.76034 electron volts, with high hardness value which make it more stable, less reactive, compound. 53. Also, the chemical potentials, pi, of these compounds are in range between -4.246 to -3.0346, which indicates that the same electron cloud and the degree of absorption of both temperature and pressure is nearly the same. Furthermore, the chemical softness, the atom's aptitude for electrons accepting, was noticed in Table 12. M5, M8, M21, and M26 had values of 0.455943 electron volts, 0.492647 electron volts, 0.373445 electron volts, and 0.452713 electron volts, respectively. Many thanks for you.
The title of my research is Soft Modification of Sawdust as an Effective Agro-Waste for Promising Degradation of Brilliant Blue Dye and Amoxicillin. Abstract agro-waste such as flakes sawdust was investigated in this study for the pollution of hazardous dyes and antibiotics. Its sustainability for the synthesis nanocomposite activated carbon source has a great attention for several angles. Chemically modified activated carbon loaded with ferrocene and a typically nanocomposite system was successfully used in the depollution aims. The surface morphology of the synthesized sample was followed by through scanning electron microscope and XRD diffraction. Introduction. Dyes have caused damage for lungs, skin, and respiratory disorders all around the world. Direct discharge of dye containing wastewater in the environment has a potential to produce dangerous carcinogenic compound. Direct and raw dye were found to be the highest level of toxicity. Antibiotics are a new class of environmental toxins that are hazardous, persistent, and bioaccumulative, and potentially antibiotics have a greater drawback than the organic pollutant in the induced bacterial resistance, making treatment more difficult. Synthesis. Sawdust was cleaned regularly with water to remove any dust from pollutant had accumulated and dried at 120 centigrade. Sawdust is carbonized at 3 different temperatures, 300, 500, and 700. In addition to the carbonized sawdust at 500 centigrade was modified with different ratios of ferrocene. The XRD diffraction showing that activated carbon is quite similar, which carbonized at 700 is quite similar to that activated carbon which carbonized at 500, and showed that the peak at 2 theta 26.5 is disappeared compared with that for activated carbon at 500. In addition to, the average grain size is decreased than that when carbonized at 300. Ferrocene based on activated carbon nanocomposite at 500 compared with XRD of pristine carbonized sawdust at the same temperature, showing 2 theta at 24, 33, 35, 41, 49, 54, 57, 62, and 63.77, which is matched well with card number as 01072 bar 0450. Morphological analysis showing that SC2 as a representative sample, showing that the agglomerates which cavities were attributable to carbonized sawdust at 30 degrees. Diffused reflectance and optical band gap analysis showing that the absorption age and optical band gap of the synthesized nanocomposite showing that the band gap was various from 5.5 to 6.3 electron volts. Catalytic performance. The result shows that the ferrocene with 1 gram at activated carbon, which carbonized at 55 centigrade, has effective photocatalytic agent with a high removal percentage. The efficiency are 93%, 92%, and 86% for activated carbon. Conclusion. In conclusion, ferrocene with 1 gram with carbonized sawdust, which carbonized at 500 centigrade composite material was generated using a simple one-pot technique and used to remove brilliant and amoxicillin. The most efficient one is ferrocene with 1 gram and activated carbon composite, which is carbonized at 500, were found to be increased, and the activity arrived to 97 and 93 for amoxicillin and brilliant blue respectively. Thank you.
Hello everyone, I'm Rania Badri. This poster under title Application of Carboxymethyl Cellulose Sodium Copper Oxide Nanocomposites as a Sensor for NH3, H2S, and HBr gases modeling approach. As we know that semiconductor metal oxides are excellent candidates for optoelectronic devices because they have unique optical and electronic properties. Thus, inorganic semiconductors that utilize transition metal oxides like copper oxide, zinc oxide, and titanium dioxide have attracted increased interest. Recently, the detection of toxic gases has been categorized through highly explored detection techniques. Among them is the molecular modeling, which is one of the most rapidly processing areas in science that can make a connection between experimental and theoretical work. To the best of our knowledge, the sensitivity of CMC to NH3, H2S, and HBr gases have never been tested before theoretically. The main objective of this study is to study the surface interaction between CMC and copper oxide and to predict the sensitivity of the proposed structure of CMC copper oxide model molecules to the different gases H2S, NH3, and HBr. All calculations were carried out using density functional theory as implemented in Gaussian 09 package at Spectroscopy Department, National Research Center. Model molecules representing dimer CMC and its nanocomposite are subjected to optimization at the B3 lib LAN L2DZ level of theory. In building our model molecules, 2 units of CMC are supposed to interact with 1 molecule of copper oxide. The interaction of copper oxide with CMC was supposed to be throughout the oxygen atom of the metal oxide and the functional group of the polymer. Thus, as we can see from figure 1, that the proposed structure of CMC contains 8 active sites. These active sites are the hydroxyl group attached to the different carbon atoms and the C double bond O group, and finally the O linkage along the chain of the CMC. Additionally, the interaction between copper oxide and CMC can occur throughout complex interaction and adsorbed interaction. As we can see from table 1, that the total dipole moment of the complex interaction increases by changing the position of the interaction. Meanwhile, homo-LUMO band gap energy values changes by changing the position of the interaction. And we see that the position named P3 has the highest total dipole moment and the lowest homo-LUMO band gap energy. Meanwhile, for the adsorbed interaction, we observe the same sequence, that the total dipole moment changes by changing the interaction site, and the homo-LUMO band gap energy also changes. And by comparison, these two tables shows that the most interaction mechanism will be that occurs throughout the adsorption interaction, as it has the lowest homo-LUMO band gap energy, which means that the most probable interaction to occur. Additionally, the sensitivity of the proposed structures of CMC and copper oxide to the H2S, NH3, and HBr gases are also studied in terms of the total dipole moment and homo-LUMO band gap energy as presented in table 3, as the reactivity of the different structures is closely related to the band gap energy between their homo and LUMO orbitals. At that point, the higher the reactivity, the smaller will be the band gap and the lower will be the stability, and the total dipole moment will be the higher. Also, this figure indicates that, this table indicates that the reactivity of the CMC copper oxide structure increases as a result of the interaction with the different gases, which means that the proposed structure of CMC and copper oxide can be used as a gas sensor for NH3, H2S, and HBr gases. Hello everyone, I'm Rania Badri. Our poster today will be about highly sensitive hydrogen sulfide gas and methylene blue dye sensors based on carboxymethyl cellulose, sodium, and copper oxide zinc oxide core shell, a DFT study. As a result of the rapid industrialization, which has resulted in a growth in the quantity of harmful and dangerous gases in the atmosphere, the environmental pollution has lately reached an alarming level. As a result, creating sensors capable of detecting hazardous and dangerous pollutants is important. Zinc oxide nanoparticles are one of the most significant and functional materials due to their wide band gap. However, they are only active in the UV region. Thus, a variety of methods including doping, surface modification, and the creation of composites have been used to enhance the sensing performance based on zinc oxide to make it active in the visible region. Thus, coupling zinc oxide with semiconductors having a narrow band gap is one technique to boost its photoactivity under sunshine. Thus, in this study, time-dependent density functional theory calculations were carried out for the optimization of copper oxide, zinc oxide, and copper oxide zinc oxide core shell structures. The major aim of our study is to enhance the sensitivity of copper oxide and zinc oxide by making a core shell structure, and to study the sensitivity of CMC copper oxide zinc oxide core shell to H2S gas and to methylene blue dye. Figure 1 shows the optimized structures of copper oxide, zinc oxide, and core shell structure. As we presented that in Figure 2, copper oxide and zinc oxide have sharp peaks at 675 and 324 nanometer respectively as a dominant transition, which is shifted to 1000 and 262 nanometer for the core shell structure. The large shift in the absorption peak confirms that the molecular structure of copper oxide was changed due to the formation of zinc oxide layer. Table 1 shows the maximum absorption wavelengths and the optical band gap energy of the three structures. As indicated in the table, that the optical band gap of copper oxide, zinc oxide core shell structure is lower than that of copper oxide and zinc oxide, and this is due to the formation of the localized states within the band gap. Based on our previous work, it is concluded that metal oxides can interact with CMC throughout the hydroxyl group of CM2. Accordingly, there are two possibilities for the interaction of CMC with the core shell structure. The first interaction mechanism occurs via the hydroxyl group of the CMC and the oxygen atom of the shell. However, the second interaction mechanism is that proceeds throughout the metal atom of the core shell structure as presented in Figure 3. Table 2 presents the total dipole moment values and the HOMO-LUMO energy for these two interaction mechanisms, and it confirms that the interactions proceed throughout the oxygen atom of the shell is the most prominent one, as it has the lowest HOMO-LUMO band gap energy. The sensitivity of CMC, copper oxide, zinc oxide core shell structure to H2S gas and to methylene blue dye. As we can see from Figure 4 that there are different positions for the interaction of the H2S gas and methylene blue dye with CMC, copper oxide, zinc oxide core shell structure. Table 3 and Table 4 presented the obtained values of the total dipole moment and HOMO-LUMO band gap energy for the CMC structure core shell interacted with H2S at the different positions and with the methylene blue dye at the same positions. It's clear that the values of total dipole moment and the HOMO-LUMO band gap energy different by changing the position of the interaction, which means that the proposed structure of CMC and core shell structure is more sensitive for the H2S gas and methylene blue dye. Our conclusion is that as the total dipole moment of CMC and copper oxide zinc oxide structure increases and the HOMO-LUMO band gap energy decreases upon the exposure to the H2S gas and methylene blue dye, it can be concluded that the proposed structure of CMC and the core shell may be a promising material for the detection of H2S gas and methylene blue dye. Thank you.
Booster number 41, molecular modeling and biological activities of metal oxide modified bioactive glass, presented by Taha Taima. Bioactive glass was prepared by sol gel method following composition 60 silicon dioxide, 34 calcium oxide, 6 P2O5, where X equal 10 from Fe2O3, copper oxide, zinc oxide, and germanium oxide. Samples were then studied by FTIR and biological activities of studies sample were proceed with bacterial test. Model molecules for different glasses composition were built in calculated with density function theory at P3 lib 6 31 PD level. Some important parameters such as total dipole moment, molecular electrostatic potential based infrared spectra were calculated. Modeling data indicated that before O10 vibrational characteristics are enhanced by addition of silicon dioxide, calcium oxide due to electron rush resulting along wall crystal. Additional zinc oxide to B4O10 silicon dioxide, calcium oxide, had high impact on vibrational characteristics. On contrary of other alternative, copper oxide, iron oxide, and germanium oxide that had lower change in spectral index.
Cadmium sulfide semiconductor materials has dielectric band gap 2.4 electron volt and has several applications in high efficiency solar cells. Recently, cadmium sulfide doping with magnetic metal transition element as called dilated semiconductor materials. In this paper, we prepare cadmium sulfide doping with manganese by chemical methods and can study the structural properties and the dielectric properties to use in several applications such as digital recording media. From figures, we can confirm the structure of cadmium sulfide by EDX technique and obtain cadmium sulfide is nearly stoichiometry. And also we can study the former transformation infrared technique and can confirm that cadmium sulfide is formed. By doping manganese in cadmium sulfide, the dielectric properties is improvement. From figures, we can study the AC conductivity and dielectric constant and electric modulus. And we can obtain the target from this paper that the dielectric parameters are enhanced to use in different applications such as promising applications and data storage service devices. Thank you.
Spectroscopic studies and antibacterial activities of 11H indino 12B كينوكسالين 11 أون. القائمين بالبحث: داليا أنسي، دكتورة هبة متولي، دكتور أشرف السيد. Introduction. تصدر البكتيريا infectious disease, photospoilage, corrosion of industrial materials and much more. ومن المشكلات العالمية التي نواجهها هي البكتيريا المقاومة للأنتيبيوتيك الناتجة من excessive use and abuse of antibiotic. العديد من الأدوية والتفاعلات الكيميائية المهمة للبيولوجي تحتوي على الهيتيروسايكليك كومباوند. وجود الهيتيرو atoms or grouping of frequently imparts preference specificities in biological reaction. كينوكسالين هو أحد المويتز التي جذبت الانتباه مؤخرا due to its growing significance in the field of medicinal chemistry. The goal 11H indino 12B كينوكسالين 11 on has been tested for its toxic effect on Salmonella typhimurium, Klebsiella pneumoniae, and Bacillus subtilis, and has been investigated in depth theoretical study to structure and spectral properties. Result: the antimicrobial activity of tested compound. The compound have been examined against gram-positive and gram-negative bacteria بتركيز 20 ملي مولر by Wells diffusion method, and inhibition zone was measured and recorded. MIC of tested compound. We have two definitions, MIC and MBC. MIC is the lowest concentration of antimicrobial inhibit the visible growth of bacteria, but MBC is the lowest concentration of antibacterial agent kill particular bacterium. The MIC value and MBC value was measured and recorded in the table against Salmonella typhi, Klebsiella pneumoniae, and Bacillus subtilis. Compound resistant variant. In case of Salmonella typhi and Bacillus subtilis, figure A and C, the bacteria show no resistance against the compound with all dose. But in case of Klebsiella pneumoniae, figure B, the bacteria show resistance at the 5th day with 1x MIC dose.
Computational study, the quantum chemical calculation study of our compound at function PLY3B6311++G was performed to explore the structure and spectral properties. والنتيجة geometrical parameter and NMR spectra. geometrical parameter باستخدام الدف توضح إن المركب have bond length and bond angle وكانوا very close to the X-ray reported value with deviation موجودة في البوند with different color 0.1 and 0.7 angstrom وبالتالي the dihedral angle data show little deviation 175.12 and 3.70 while the X-ray value were 179.99 and 0.02. NMR spectra في توافق ما بين calculated and experimental proton NMR with deviation 0.21 to 0.43. For example, the calculated proton 1 and proton 6 present at 8.17 and 7.84 بينما الإكسبerimental show at 8.51 and 8.08 and the carbon 13 calculated show in range 125.78 to 197.29 with average difference 2.32 to 7.98 while the experimental in range 122.29 to 189.31. This research examines the antibacterial activities of our compound. In vitro, the antibacterial activities of the compound were carried out against the culture of bacteria. The compound showed remarkable antibacterial activity. The comparison between calculated optimized structure geometry and spectral data, proton NMR and carbon 13 NMR with experimental data display acceptable agreement. Thank you.
Antibacterial effect of microsynthesized nanosilver against multi-drug resistant bacteria. النشر بواسطة ندى حسني غزالة ومساعدة كل من الدكتور أشرف السيد Botany Department Faculty of Science منصورة University ودكتور محمد عثمان عبد المنعم Botany Department Faculty of Science بنها University. Introduction. Multi-drug resistant bacteria are a serious and increasing health problem. Therefore, there is an urgent need for the development of other cost-effective and efficient antimicrobial agents that overcome antimicrobial resistance. Nanotechnology can be a very promising approach in this problem. Nanotechnology is the process of creating particles that are in the nanometer range between 1 and 100 nanometer. Microorganisms have been explored as potential biofactors for synthesis of metallic nanoparticles such as cadmium, sulfide, gold, and silver. Silver nanoparticles have inhibitory effects on the growth of bacteria, virus, and other eukaryotic microorganisms. The aim of this study to search for an effective antimicrobial agent against the multi-drug resistant bacteria. A result, microsynthesis of silver nanoparticles. Figure 1. The growth of Fusarium oxideboron in MGYB media A before B after. Figure 2. Fungal cell free filtrate with silver nitrate before and after incubations showed in picture C before and picture D after. Characterizations of silver nanoparticles. Figure 3. UV spectral scan from 350 to 500 nanometer of microsynthesized of silver nanoparticles indicates a characteristic peak at 438 nanometer. Figure 4. Scanning electron microscopy. Silver nanoparticles were almost round shaped of size less than 100 nanometer. Figure 5. 10 micrograph of microsynthesized of silver nanoparticles. This image shows spherical or oval shaped of nanocolloids with average size 6 to 15 nanometer. Figure 6. This micrograph of the selected area diffraction pattern for 1 nano silver particles revealed that silver atoms which appeared as light spots were present in the diffraction ring. Figure 7. The value of zeta potential of silver nanoparticles minus 17 MV indicates the stability of the nanosilver. In addition, the conductivity, which is 0.1, indicates stability. Figure 8. At X spectra of silver nanoparticles, the optical absorption peak is observed at 3 keV and the weight percent of silver as 70%. Table 1 showed the MIC of silver nanoparticles on microbial growth, Staphylococcus aureus and Klebsiella pneumoniae. The concentrations which total inhibitions of the bacteria is 10 microgram per ml. Table 2. The inhibition zone of silver nanoparticles and the antibiotic on Staphylococcus aureus and Klebsiella pneumoniae. The inhibition zone of silver is larger than the inhibition zone of an antibiotic, so the inhibition zone is the largest when we make mixtures with silver nanoparticles with an antibiotic. Ultrastructure of that treated multidrug resistant bacteria by TEM. Figure 10a. Changes in Klebsiella pneumoniae cell structure observed by TEM with or without silver nanoparticles. Figure 11b. Changes in Staphylococcus aureus cell structure observed by TEM with or without silver nanoparticles. Molecular characterizations of the treated multidrug resistant bacteria by rapid analysis of DNA. Isolated bacteria treated Staphylococcus aureus and Klebsiella pneumoniae with silver nanoparticles that showed by present or absent the bands. Protein binding profile of the treated multidrug resistant bacteria. Protein profile with silver nanoparticles is the first line MF protein ladder. C1 is the control of Staphylococcus aureus and number 1 is the Staphylococcus aureus with silver nanoparticles. C2 is the control of Klebsiella and number 2 is the Klebsiella with silver nanoparticles. New bands are denoted by a black arrow, while bands that have disappeared are indicated by a red arrow. Analysis of the multidrug resistant bacteria's protein binding pattern after exposure to silver nanoparticles, which indicated that there are 28 bands, totally as 7 monomorphic, 13 polymorphic bands, and 8 unique bands. Conclusion. This study has shown that silver nanoparticles have significant antibacterial effect on multidrug resistant bacteria, regardless of its susceptibility to antibiotics. The data presented in this work are novel, so it could lead to new advances in development of antibacterial agents that could overcome the multidrug resistant. However, further studies have to be conducted on the toxicity level and possible adverse effects that could arise in the use of silver nanoparticles as an effective antibacterial agent in the healthcare system.